This week, we are going to discuss the longest increasing subarray problem. The problem is like that you are given an array and you have to return the length of the longest increasing continuous subarray. That is, like if you have an array 1, 4, 3, 2, 4, 6, 9, 11, 3, 7, the output should be 5 because the longest increase in subarray is 2, 4, 6, 9, 11. Before going through the further video, I would suggest you to try solving the problem on your own. Many of you would be able to determine its solution very easily, but still most of you would stuck in between while writing the code. So please do not neglect that part and try writing the code for it. This problem has been recently asked by Facebook, Amazon, Uber and many other companies. And another reason for discussing this problem is that it includes various concepts which can be reused at various places like sliding window, dynamic programming, time and space complexity and many other. Let us analyze this problem. How would we analyze it? What would be the most obvious approach? The most obvious approach in everybody's mind would be to check all the subarrays and return the longest increasing subarray. See, this approach does not require extra memory, but we see that its time complexity would be n square. Because in first loop, we would take the smallest subarray and would check in the complete array if we could get the longest subarray. Then we would increase the subarray to size 3 and then again traverse the complete array. And similarly, we would repeat the same process for the subarrays of size 4, 5, 6, 7, 8 and 9. And we would keep on checking whether we can get a subarray which is increasing as well as it's given the maximum length. So n times n elements are being traversed, hence complexity would be n square. But this is not what is expected from you during the interviews. There you are expected to give the most optimal solution. But it's a suggestion that when you are asked such problems in the interviews, do not skip them. Do mention the approach briefly and clarify that this is not the most optimal one. Now think about the solution to make it faster. Just start thinking in this way that if we want to make this problem faster, what can be the scenario of time complexity? It can be n log n or log n or 1. 1 cannot be 1 as we need to traverse the array at least 1. So it might be log n. It means we are dividing the array at every step and are considering only one part of the array and ignoring the other. This also cannot be the case, as the subarray cannot be present in one part of the array. It can be a union of elements from both the parts. Now it might be big O of n or big O of n log n. If it's n log n, it usually means that we are doing something like sorting, binary searching and so on. But since we do not want to change the order of the array, so sorting is not useful and binary search also seems irrelevant. So the possible solution can be of big O of n. It is not at all necessary that the solution can have only big O of n time complexity and rest time complexities are impossible. But it can be said that big O of n have greater chances to be a solution. So now as big O of n is somewhat like the target, it means that we need a technique that traverses the element of the array only once. So we would target on this time complexity. Now suppose our sample array is an array of 10 elements, that is 1, 4, 3, 2, 5, 6, 9, 11, 3, 7. We can take an approach that we take two pointers start and end, which would point to the first element initially, and suppose our initial maximum length of the subarray is 1. Now we would increment our end pointer till we get an element which is not contributing to the increase in subarray. So currently we can see that the current length of the subarray is 2. We would increment the end pointer, it would come to 3. Now we can see that 3 is the element which is not contributing to the increase in subarray. So it's an end. Now update the maximum length of the subarray. As current length, that is 2, is greater than the previous max length, that is 1, so new max length would be 2. Now bring the start pointer to this end pointer and start incrementing the end pointer. Now the current length of our subarray is 1, that is the element 3. Move the end pointer forward. Our current length would be 2, but we see that again we have found an element which is not contributing to the increase in subarray. So update the max length of the array. As current length is less than the previous max length, so no need of updation. Maximum length still remains 2. Bring the end start pointer to the current end pointer. Increment the end pointer and update the length, that is 2. Increment the end pointer, update the current length, that is 3. And keep on repeating this process. Current length is 5 now. Now we increment our pointer to 3. We see that we again have an element which is non-increasing. So this is end of the array. As current length, that is 5, is greater than the previous max length, update the max length. It would be 5. Bring the start pointer to the current end pointer. Repeat the same process. End pointer would go to 7. Current length would be updated. That is 2. End pointer incremented. But we see this is an end of the array. So we see that maximum length of the subarray which we have received till now is 5. So what's the pseudocode we have actually followed is that we have initialized the start and the end pointer to 1, maximum length of the subarray to 1, and we have repeated the procedure till we reach to the end of the array, and we keep on comparing. If the end element is greater to the previous element, update the length and increment the end pointer. And if we get a non-increasing element, check if your current length is greater than max length, update the max length, calculate the current length, increase the end pointer, and repeat this complete process till the end of the array is reached, and return the max length at the end. Now let's have a look at the extension of this problem. Let's change the problem that what would be the technique if you are required to return the subsequence and not subarray. That is, elements should not be continuous. Like for this array, the output would be 1, 2, 5, 6, 9, 11. I would leave this problem as an homework for you. Array problems are too popular in tech interviews as they need no prior knowledge, and they are a good way to test candidates' logic and coding skills. Solutions are never tough to think, but writing the bug-free code, and that too optimized one, within the time constraint is the main challenge. So keep practicing, keep coding. Thank you for watching. Next video would be there next Friday. Till then, stay tuned and subscribe to our channel.